Let's take a look at some factoring strategies. This is really just going to be going through the AC method, greatest common factor method, and any other techniques that you would like. So here I've got 4x squared plus 26x plus 12. No matter which method you're using, it's a really good idea to start with factoring out the GCF. So in this case, 4, 26, and 12. These are all even numbers, so I know that 2 goes into each of these. 2 times 2 gives me that 4. 2 times 13 gives me that 26. And 2 times 6 gives me that 12. I'm left with 2x squared plus 13x plus 6, and I'm just going to keep factoring these pieces until I can't factor them anymore. Now, if I'm trying to factor 2x squared plus 13x plus 6, you can use the AC method, or you can use something like a box method. I'm going to do the AC method here. So I've got 2x squared plus 13x plus 6. I'm going to list everything that multiplies to my A times C. 2 times 6 is 12. And I want them to add to that middle term of 13. So I always like to start with the number 1 as I'm looking for multiples. 1 times 12 gives me 12. 1 plus 12 gives me 13. And you know what? I got it right off the bat. If I check the other ones like 2 and 6, I'll see that these don't add up to the number that I'm looking for. So I'm really looking for this magic pair that multiplies out and adds out correctly. So with the AC method, it takes the center term and it splits it up. So I'm going to have 2x squared and still having the 6. And I'm splitting up this 13 into a 1x and a 12x. Now that I've done this, I can try grouping. So I can try to group the 2x squared with the 1x and the 12x with the 6. And I'm going to do that here. So this 2x squared plus 13x plus 6, I've got 2x squared with 1x plus, and this is all inside of parentheses, 12x plus 6. And I'm just going to keep working on that inside. So 2x squared and 1x, these have x in common. 2x times x gives me 2x squared. 1 times x gives me 1x. 12 and 6, that has the number 6 in common. 6 times 2x gives me the 12x. 6 times 1 would give me a 6. When I factor with the AC method, I'm always going to end up with a shared factor. In this case, 2x plus 1. That 2x plus 1 looks like it's getting hit by an x and a 6. So if I factor 4x squared plus 26x plus 12, I'm left with 2 times 2x plus 1 times x plus 6. Let's try another one. Factor 6x cubed minus 6x. Okay? First step, I'm pulling anything that they have in common out. They both have a 6 and they both have an x. 6x times x squared, I've taken away one of the x's, I still have 2 left, gives me the 6x cubed. 6x times 1 gives me this minus 6x. This looks like I'm already done, but I'm going to try to break up this x squared minus 1 a little bit more. And I'm hoping that this is going to be some sort of x, x, with two numbers here that hopefully multiply to give me the constant and add to give me the middle. So I'm looking for things that multiply to -1, my constant, and I want them to add to the middle number. Now in this case, x squared minus 1, I don't just have x on its own in the center. So my b term is 0. I don't have just x inside of this center little piece. So numbers that multiplied to -1, well, I don't have too many options. -1 and 1 multiply to give me -1. If I add these together, luckily, that gives me 0. So the set that works, x with a -1 and x with a +1. So if I'm factoring 6x cubed minus 6x, I should end up with 6x times x minus 1 times x plus 1. Finally, let's look at 8x squared plus 28xy plus 20y squared. There are a lot of different ways of doing this problem. But the first thing that I want to do is pull out anything that they all have in common. 8, 28, and 20 all have the number 4 in common. Pulling out that 4 leaves me with 2x squared. That leaves me with a 7xy, 4 times 7 is 28, and a 5y squared. 4 times 5 gives me the 20. I'm left with this 2x squared plus 7xy plus 5y squared piece. And I'm going to factor that using the AC method again. So I want things that multiply, doing a little scratch work on the side, to my A times my C. In this case, I have 2 and 5. 2 times 5 gives me 10. And I want it to add to the middle number. My middle number here is 7. Now you might be seeing this x squared and this y squared, and you're wondering, how is this even going to work when I have these different letters? Well, I'm still trying this AC method. I just want to see what happens when I do so. 1 times 10 gives me 10. That adds up to 11. That doesn't work. 2 times 5 multiplies to 10. 2 plus 5 gives me 7. That does work. So the way that the AC method works is it takes whatever you have in the center, whether this be x, a y, or an x times y, and it breaks that number up, 2xy, 5xy, so it's easier to deal with. So the letters stay the same, I'm just breaking up the number as a 2 and a 5 to get a 7. From here, I'm going to factor by grouping. And I might try to group these first two things together and these last two things together. So if I'm looking at 2x squared and 2xy, these both have 2x in common. X times 2x gives me 2x squared. 2xy, if I've taken out the 2x, I still have a y left there. If I'm looking at 5xy and 5y squared, these both have a 5y. If I've taken out the 5 and the y of the 5xy, I still have x left. 5y times y gives me the y squared, 5y squared. So by doing this AC method and splitting it up, and then factoring by grouping, I have the same factor that's being shared. So I have 4, and I have this x plus y that's showing up for both those chunks. That's getting multiplied against 2x and 5y. When you're multiplying everything together, I don't need this extra set of parentheses, so you could just write this as 4x plus y, 2x plus 5y. If you prefer using something like the box method, or if you have another way to visualize this, I would strongly encourage you to do so. A big part about problem solving is just trying things out and seeing what works out best for you.